Welcome back to our channel. In today's video, we take a deep dive into the testing of the topic electrochemistry. This remains your Kenyan teacher, and this is K.C.S.E. Chemistry Paper 2 for the year 2024. Electrochemistry was tested as question number 4. Stay tuned. Table 2 shows standard reduction or standard electrode potentials for given half cells. So we have table 2 with a total of 6 half cells. The first one being of nickel, E0 value negative 0.25. Half cell 2 is for cadmium, E0 value negative 0.40. We have half cell number 3 for aluminium, negative 1.66 is the E0 value in volts. Number 4, we have half cell that represents reduction of manganate 7 ions to manganese 2 ions, accompanied by positive 1.52 volts as read in the voltmeter. Number 5, we have reduction of ion 2 ions to ion, negative 0.44. And finally, at number 6, we have silver ions being reduced to silver. The reading on the voltmeter is positive 0.80. We now proceed to look at the questions that were tested based on the table. Part A, Roman 1. Draw a labeled diagram of an electrochemical cell using half cells 2 and 3 for 2 marks. This is a very common question, and we've always advised our students to first take note of the E values of the cells in question. So we have cell 2 involving cadmium, negative 0.40, and half cell 3 is for aluminium, negative 1.66. So once a candidate has identified the half cells as per the question, we gave a very simple method that a student should use to help in placing the half cells. Remember, one of these half cells must be placed on the left-hand side and another one must be placed on the right. So here goes the memory tool. And we always said that between the two that we have selected, a candidate should be able to identify the one that is most positive. And you agree with me that negative 0.40 is more positive than negative 1.66. This depends on your understanding of a number line as discussed in mathematics at Form 1. Now, second memory item is that the half cell with the most positive E0 value is the stronger oxidizing agent. Third memory item is that this oxidizing agent will always be reduced during the reactions. The fourth item that we have always discussed with our learners is the reduction process usually occurs at the cathode. And finally, as we draw the complete cell, as demanded by our question, cathode is the one that is always put on the right hand side. So for that reason, cadmium, which has the more positive inert value as compared to aluminium, will therefore be placed on the right hand side of our electrochemical cell. Now with that information, we can now go ahead and draw our complete cell so that we bag the first 2 marks of question 4. So quickly, we shall draw the container on the left. This container should contain aluminium ions because we've agreed cadmium will be on the right. To be more accurate, we need to also put the concentration. Then on the right, we draw another container that will now have cadmium ions as our electrolyte. Of course, it can be 1 mole as well. Now, in between the 2 electrolytes, we have what we call a salt bridge that will help in completing the circuit. Don't forget, the question is asking us to do what? To label. So this is our salt bridge. Now, we need to put in our electrodes. The electrode on this end is aluminium strip. The electrode on the half cell on the right hand side is cadmium strip. And then of course, these electrodes are now joined with ordinary copper wire, of course via a voltmeter. So this forms our complete cell and it is worth 2 marks. So the electrode and the electrolyte, of course correctly drawn, the first half mark. For the half cell on the left, the same, electrode together with its correct electrolyte, half mark. Salt bridge, half mark labeled, and the voltmeter, another half. Total 2 marks. For Roman 2, the examiner expected us to calculate the EMF, the electromotive force of our cell. And here, for our candidates, we say there is a formula. The EMF of a cell is given by the E naught of the reduced half cell minus E naught of the oxidized half cell. We've agreed that cadmium is going to be reduced. That's why it's on the right hand side. Aluminium is going to be oxidized. The E cell for cadmium is negative 0.40 and that of aluminium is negative 1.66. If you do the calculation here, we get a net of positive 1.6 volts. Of course, 1 mark, the calculation showing the working half mark, and the answer another half. Roman 3 is demanding that our students should write the equation for the electrochemical cell. And remember, we did a simplified video on how to do this, but for purposes of this video, we shall repeat. And we remember telling you that the first thing you do is to consider the 2 half cells again. So half cell 2 involves reduction of cadmium ions through acceptance of 2 moles of electrons to give cadmium. Half cell 3 involves reduction of aluminium ions through acceptance of 3 moles of electrons to give aluminium. Once you have considered your half cells in question, we advised that a candidate should go ahead and identify the one that will be oxidized. And we had agreed cadmium will be reduced because it has a more positive E0 value. So the oxidized species is now aluminium. So from here, we were to reverse, because as we have written this equation here, acceptance of electrons is reduction. But in real sense, this should be oxidation. So we reverse the equation by starting from the products and ending with the reactants. So this now shows actual oxidation. So we now take note of equation 1 and equation 3. They will be of help as we continue to write the equation for the electrochemical cell. So next step is to balance the moles of electrons for our two equations. Here is 2, here is 3. So we need to multiply equation 1 by 3 and equation 3 by 2. So if we do so, equation 1 now becomes 3 moles of cadmium ions accepting 6 moles of electrons to give 3 moles of cadmium. Equation 3 will be 2 moles of aluminium forming 2 moles of aluminium ions through acceptance of 6 moles of electrons. After this, we want to cancel out the electrons for the two equations, and then we rewrite the equation afresh through addition of the two. So on the reactant side, I will have 3 moles of cadmium ions reacting with the 2 moles of aluminium to give, on the right or on the product side, I have 3 moles of cadmium together with 2 moles of aluminium ions. So this becomes our equation for the complete electrochemical cell. It's a long process, but worth just 1 mark.